So let's look at the following example that deals with the conservation of energy. So, suppose two railroad cars are traveling toward each other with a velocity of 100 kilometers an hour. Now each car has a mass of 60,000 kilograms. They collide head-on and come to a complete stop. We want to find the amount of thermal energy transferred in this collision. So this is our diagram. Our two cars, which have the same exact mass and are traveling with the same exact magnitude of velocity but different directions, are traveling at each other or toward each other. Now they collide head-on and come to a complete stop. So their velocity in this point, in the final point, is 0 of both cars. So we want to find what the final thermal energy is, how much energy was transferred in this collision. So the first step is to basically convert our velocity into meters per second, because we're going to need that. So the way we convert that is simply multiply by 1,000 because there are 1,000 meters in a kilometer, and then divide by 60 times 60, or 3,600. And that's because there are 60 seconds in a minute and 60 minutes in an hour. So 100 times 1,000 divided by 3,600 gives us 27.78 meters per second. So our two cars are traveling with 27.7 meters per second of magnitude at different directions. So we're going to use the fact that energy is conserved. So the amount of energy we begin with is equal to the amount of energy we end with. So initial energy is equal to the final energy. Initial meaning this system, final meaning this system, when the two cars come to a complete stop. So initially, what was our energy? Well, since our height is 0, there is no gravitational potential energy. All the energy comes from our velocity or motion of the objects. So 1/2 m1 v1 squared plus 1/2 m2 v2 squared, where m1 is this mass and m2 is this mass. v1 is the velocity of this object and v2 is the velocity of this object. Now, going in this direction, our velocity is positive. Going in the reverse direction, our velocity is negative. And this equals to, well, what's our energy in the final state? Well, our energy due to the gravitational potential is still 0. Our height has not changed, but our velocity is now 0, and that means there's no energy due to motion. So all the energy must have gone into increasing the temperature of the cars as well as the temperature of the surroundings. So this is known as thermal energy. So we want to find what this value is. So we basically take our knowns and plug them into our variables here, and we get the following. 1/2 times 60,000 kilograms multiplied by 27.78 meters per second squared plus 1/2 60,000 kilograms multiplied by negative 27.78 squared, because this object is going in this direction in the opposite, but since we're squaring, this negative will go away. So we simply add these guys up and we get the following value. 46,303,704 joules of energy is transferred when our collision occurs. And this energy is transferred into increasing the temperature of our objects as well as the temperature of our surrounding system, our surrounding air. So this is the amount of energy that was transferred in the form of thermal energy.